Hello, good morning. Welcome to my stream. I am going to try streaming day 21 of Advent of Code, and I'm getting a very late start, unfortunately, because things are a little hectic around here. I don't know how long I can go and how difficult the problem is, but we'll see. Let's switch over to my screen and switch over to the Advent of Code. Right, we were looking at day 19 yesterday. All right, so we're on day 21. Let's get set up for day 21. All right. I think we're all up to date, right? Status. Yes. Good. Day 21. Day 21, Dirac dice. Paul Dirac was a mathematician, right? Yeah. A physicist. All right. Lucasian professor of mathematics at Cambridge from 32 to 69. That's a long period of time. Okay. Getting distracted. There's not much to do as you slowly descend to the bottom of the ocean. Submarine computer challenges you to a nice game of Dirac dice. This game consists of a single die, 2 pawns, and a game board with a circular track containing 10 spaces marked 1 through 10 clockwise. Each player's starting space is chosen randomly, your puzzle input. Player 1 goes first. Players take turns moving. On each player's turn, the player rolls the die 3 times, adds up the results. Then the player moves their pawn that many times forward around the track. That is, moving clockwise on spaces in order of increasing value, wrapping back around to 1 after 10. So if a player is on space 7, they roll 2, 2, and 1. They would move forward 5 times to spaces 8, 9, 10, 1, and finally stopping on 2. After each player moves, they increase their score by the value of the space their pawn stopped on. Players' scores start at 0. So if the first player starts on space 7 and rolls a value of 5, they would stop on space 2 and add 2 to their score for a total of score of 2. The game immediately ends as a win for any player whose score reaches at least 1,000. Since the first game is a practice game, the submarine opens a compartment labeled deterministic dice, and a 100-sided die falls out. This die always rolls 1 first, then 2, then 3, and so on up to 100, after which it starts over at 1 again. Play using this die. All right. I'm trying to think what's part 2 then? Is just using a random die? Oh, hi, Mr. Glitchbite. Thank you for the raid. Good to see you. We're just starting with Advent of Code day 21. For example, given these starting positions, 4 and 8. Oh, I guess it's going to be limited inputs this time, right? Because there's only 100 possible combinations. So we got 3 and 5 here. And 4 and 8 they can't use because they have the answers. So there's only 99 possible player inputs. Or, game inputs. Anyway, okay, this is how the game would go. Player 1 rolls 1, 2, 3 and moves for a total score of 10. It's going well, Mr. Glitchbite. Did you stream Advent of Code, or are you working on something else? Player 2 rolls 4, 5, 6, moves to space 3. Okay, I think I understand what's going on here. And then player 1 rolls 91, 92, 93 and moves to space 10 for a final score of 1,000. OSCP. That's a security thing, right? Cybersecurity thing. I'm not that familiar with it, so maybe I'm wrong. Since player 1 has 1,000 points, player 1 wins and the game ends. Right. At this point, the losing player has 745 points, and then the die has been rolled a total of 993 times. We multiply those two numbers together, and we get this. All right. OSCP stands for Offensive Security Certified Professional. Okay. So you're becoming a professional offensive person. Oh, pen testing. Yeah. Okay. It sounds like a pretty cool profession. I wish you the best of luck with that. It's very important for security, pen testing. All right, play a practice game using the deterministic 100-side die. Oh, thank you very much, Gazal. Thank you for the follow. All right, so, I mean, we have our puzzle inputs, just two numbers. We can hard code those. How hard can that be? But let's see if we can simplify this, because I know part 2 is just going to be simulated a billion times or something crazy like that. Oh yeah, you're trying to write your tools in Rust. That makes sense. Rust is geared towards memory safety and security in that fashion. So hopefully that works out well. So 1, 2, 3, which is 6, and then 4, 5, 6, which is 15. 7, 8, and 9. So we're adding 9 each time, right? We start at 6, then we go to 15, then we go to 24, and then we go to 33. So this is just going up by 9 each time. So I guess we could simplify things by starting out that way. Right? Well, let's give that a shot. First, we need to set up our runner here on day 21, and put day 21 down here, and then make dir, and then edit source day 21 mod.rs. And then this should just run. Yes, okay. So we're at the point where we can actually do cargo checks and things. Good. So we're gonna use this input here, just to start out with. P1 pause is 4. P2 pause is 8. And then what we're gonna do is just start and roll the die. We'll simulate a roll just by incrementing things, right? If we start out, we can just get a roll count. Start at 0. And then we can say while P1 score, oh, we don't have a P1 score. Let mod P1 score equals 0 and P2 score is 0. While they're both less than 1,000. What are we going to do? We're going to add, the first time we have to add 6 to the score. Or to the position. And then add the score in of the location they're at. And then all subsequent times we add 9. So why don't we just start at -3? Is that cheating? Let's make it an I64 equals -3. And then we can just say value plus equals 9. And then we add that to the P1. Oh, and we got to keep track of our rolls. We just rolled the die 3 times. Right? And then we want to add the score that we just landed at. So the P1 position is equal to the old P1 position plus the value we just got, mod 10, but then if we wrap around to 0, this is ugly, isn't it? If P1 pause is 0, then we want to set it to 10. Because we want to add to our score the place we landed at. And then we want to do the same thing for player 2. So P2 pause is P2 pause plus value, mod 10. P2 pause is 0. P2 pause equals 10. P2 score plus equals P2. And then we should be able to say, we can print out we can see that player 2 ends on space 3 and player 1 ends on space 10. Let's print those out. Player 1 lands on and has a score of this. So P1 pause and P1 score. And then we just change all of these to 2s. Is that it? Is that the entire... I'm sure I broke something. Oh, P1. This should be P1 pause. What else is broken? Roll plus equals 3. Oh, rolls. There we go. Oh, yeah, and then we have to print out how many rolls there were. Because we're going to... we're going to multiply these two together, right? And... oh, 996. We're off by... oh, we're off by 3 because we got to stop immediately. So if P1 score is greater than or equal to 1,000, then break. This is really bad. Okay. Yeah, P1 wins first. I'm glad they had that in there because otherwise I would have gotten my actual thing wrong. Yeah, so 993, and then we have to multiply by the loser. So I think all of these are good. So we can just say println. See, this is really easy, and now I'm really worried about part 2. Day 21, part 1 is going to be the number of rolls times the lower score. So P1 score, min P2 score. All right, and this should be the 739785, and it is. All right, so now we'll put in my input, which is 3 and 5. 3 and 5. Run that. And I got this number. And that's the right answer. Okay, so that's scary because I did that in less than 15 minutes, and that means part 2 is going to be a pain in the butt. Let's do this. Git add source, git commit. Day 21, part 1. Let's get that up on GitHub. And let's find out what day, what part 2 is. Now that you're warmed up, it's time to play the real game. A second compartment opens, and this time limited Dirac dice. Out of it falls a single 3-sided die. A 3-sided die. I'm trying to picture that in my head, and I can't. As you experiment with the die, you feel a little strange. An informational brochure in the compartment explains that this is a quantum die. When you roll it, the universe splits into multiple copies, one copy for each possible outcome of the die. Oh, did Dirac deal with... was this what he was famous for? About, oh yeah, quantum mechanics and quantum electrodynamics. So yeah, probability and stuff. Yeah, all that quantum stuff. In this case, rolling the die always splits the universe into 3 copies. One where the outcome of the roll was 1, one where it was 2, one where it was 3. Okay. This game is played the same as before, although to prevent things from getting too far out of hand, the game now ends when either player's score reaches 21. So I'm not going to use any of this logic that we just did in part 1. Because look at these numbers. These are insane numbers. So we're not going to be able to just count up to those. Using your given starting positions to determine every possible outcome. Find the player that wins in more universes, and how many universes does that player win? Wow. I don't even know where to start. Okay. So I think we need to do some thinking first. So every time you roll the die, it splits the universe into 3 copies. So let's just draw a little. So we have a single die which can go into 3 different universes, but you're going to roll it 3 times. So you're going to create 9 different universes just by rolling it, right? So it could be a 1 followed by a 1, followed by a 1, or a 1, or a 2, or a 3. And then this could also be a 2 with a 1, 2, 3. And this could be a 3 with a 1, 2, 3. Right? Oh, okay, yeah. So each one of these creates 9. So there's 27 different possible... There's 27 different possibilities here, right? So if I do this, this is how I'm visualizing it here. But I think we can simplify it, right? Because you're creating 27 different universes, but we only care about the score, right? Because if you go to, there is only one path for 1, 1, 1. But if you do a 2, 2, 3, right? Total score of this universe, 2, 2, 3, is going to be 2 plus 2 plus 3. But if you do 2, 3, 2, it's also 7. Right? So does it matter? Is this the way we simplify it? Does it matter which path we take? Because in this universe, you rolled it 3 times and you've gotten a score of 7, but you also have in this universe. So maybe what we can do is just multiply by the number of times that you can get to that location. Right? Right, there's only one outcome here. This is 3. There's only one way to get 3 is 1, 1, 1. But you can get 4 and then 5. But this 1, 2, 1 is 4. And this is 4, 5, and 6. Right, so there's 2 ways to, so far there's 2 ways to get to 5. There's 2 ways to get to 4. And then 1, 3, 1 is 5, 6, 7. So maybe we can create a mapping for the number of times you can reach a particular outcome and then multiply that by how you got there. There's a way to do the die roll outcome. There's a way to do this. This is for 6-sided die. But I just don't want to do this all by hand. Right, see this 1, 2, 3 out of 46, 4. Yeah. This is for 2, and then they don't have it for 3. That's okay. Maybe we just do it by hand. I thought there would be an easy formula we can use to say, okay, well, there's only one by 3. Well, hi, Crazy Wolf. You're doing part 2 also? Do you think the 1, 2, 3 will increase over time until 100? Well, we're going to add up the scores, right? And I think the way to work this, like this is 4, 5, and 6. This is 5, 6, and 7. I already have the 7 there. And this is 2, 3, 1, which is 6, 7, 8. So this is 5, 6, 7. Yeah, I guess I'm not sure what you mean by that question. The 100 doesn't matter because the 100 was only for part 1. And then this is 6, 7, and 8. And then this is... Oh no, that's 5, 6. Yeah, 3, 2, 1 is 6. 3, 3, 1 is 7, 8, and 9. All right, so these are the probabilities. There's only 1, 3. There's a bunch of 4s. $4 $. There we go. Put that there. Put that there. It's only those. Okay, so $5 is here, here, here. This is a sloppy way to do it. I'm sure there's just a simple mathematical formula to calculate this out. Those are all the 5s. Then we have a couple of 6s. The die rolls, yeah, there's a 3-sided dice, so it's only 1, 2, or 3. And there's a 7 here. Oops. 7, 7, 7. Oh, I forgot to finish the 6s. All right, so this is 6s. We got all the 7s, and then there's 3 8s, which we can just see there, and 1 9. Okay. Oops, I didn't mean to go that far up. Okay, so these are the outcomes. We have 1 3, 3 4s, 6 5s, 7 6s, 6 7s, 3 8s, and 1 9. Does that help us at all? Does that help us at all? So player 1 will roll 3 die, roll 1 die 3 times, and get a result somewhere in here. Let's just capture this data. So we have, I just want to create a quick array here of 1, 3, 6, 7, 6, 3, and 1. All right. So these are the 3s. These are the 4s. These are how many 5s there are, how many 6s there are, how many 7s, how many 8s, and how many 9s. Sorry, I shouldn't say how many there are. It's how many ways to get. There's 7 ways to get 6. So now I can just delete all that. And let me just put this in a comment here. Like that. Okay. So if I were to write a part 2 function, what we want to do is say every time we roll a die, it's going to be one of these outcomes. So we want to add up. So we're going to loop over this array and just make pseudocode for each choice, right? Which is going to be 1 3 6 7 6 3 or 1. I'm going to write it sort of like Python, I guess. For each choice, what we'll do is we'll say, if we rolled a 3, we're going to increase the score by the choice, and then say the ways we can get that. So the number of universes increase, and it's choice. It's this choice mod 10, right? With doing the if 0 then 10. We did above, right? That was that ugly thing we did right up here, but it works. So we're going to use that again. I guess that's one thing we can reuse, and then we increase the number of universes, or multiply it, right? Multiply it by the I don't know, what do you want to call these things? By the outcomes for that choice. And I have no idea if this is going to make it go better or faster or anything. And then we have to check, right, before we do anything, before we do any of this, we have to say if the score is greater than 1,000, or 21, right? We change it to 21. If the score is greater than 21, then we want to increase, we want to have like a value somewhere which says how many times we won. So the wins will be by how many universes we're in, how many universes we had to go through to get here. And then of course we have to do each player, right? So this is just one player. Maybe we can and then once we've done this, is this a recursive thing? Do we just recurse? We say for each universe, we start off with one universe and our current score and choice, and then we just call in to that. This math stuff hurts my brain. I am not good at this. I don't know if you can tell. I am just not good at this. So if I create a function, let's just call it part 2. And we can say we're going to give it the current player's score, or player 1 score. I don't even know what I was using up there. U64. And a player 2 score of U64. And the number of universes we use to get here, right? I'm still thinking this is going to be some sort of a recursive thing. We'll need more information. We'll need the player position. Yeah. Oops. Well, let me just think about calculating the score. If P1 score is greater than or equal to 21, then we need some way of storing, of adding up the wins. I'm just going to put wins, P1 wins, plus equals the number of universes we use to get here, and then we return. And then we'll do the same thing for player 2. This is kind of unusual way for me to code. I don't usually write code that's kind of half pseudocode and half not pseudocode, but that's what I'm doing just to try to wrap my brain around this. So this is very okay. And then we'll need this array, and I can just make it a const. Uni. And these are just going to be 6 of these guys, right? Okay. And then now we want to loop over them for u in uni. Oh, we want to do we want to get the count also, or the score, the roll outcome. So we can do enumerate, I guess, here. Like that. And then we did this part here, sort of. And now we need to do this part here. we need to know whose turn it is. Okay, let's make that a Boolean. Turn, bool. Let's say P1 turn. Because we want to add their universes for them. So if it's P1's turn, what are we going to do? We're going to add the score. Not the score. We're going to add the. We're going to create the score from our current position. Oh, which we need. Okay, we're just adding extra parameters here. So P1 pause is a U64, sure, and a P2 pause is a U64. So we have the current position. We'll call it next. All I did here was just add it directly. But this is, I don't want to pass mutables around. So we'll say P1 next is equal to the current position plus, this is going to go 0 through 6, right? 0, 1, 2, 3, 4, 5, 6. So that means we want to add 3 to it for the actual score, right? Because it's going to go 3, 4, 5, 6, 7, 8, 9. And then we just mod 10. And then we do the same thing here. P1 next is 0. P1 next equals 10. And then we're going to recurse. And then try to get this down. So we're going to pass in, what, part 2. What do we need to pass in? We just say not P1 turn. Just to be explicit about that. I guess I could pass in false, but that makes it clear what we're doing. And then we have to pass in, oh, that's in the wrong order. We have to pass in the score plus whatever additional, the next position, right? This is P1 next is the old position plus the new position. So our P1 score is going to get increased by P1 next. The player 2 score doesn't change. So that stays the same. It's not the player's 1 turn now. And our next position is next. And player's 2 position is not changing. And then this is where we do the fancy trick of saying universes is what I called it up here, times U. And that should recurse down until we hit is this even going to work? And then else would just do the same thing for player 2. So copy this. Oops, paste it down here and change these to 2s. And now the player 1 score stays the same. And player 2 score gets increased by P2 next. Then player's 1's position doesn't move, and player 2's position goes to next. And this should finish relatively quickly, right? Because we're only going to go till the score hits 21. And we keep just multiplying the number of options for the universe. All right, so the only thing we're missing now is how to keep track of the wins. These things here. How do we do that? Ideally, we should have just a global variable, but Rust is not copacetic with globals. So what's the best way? What's the best approach for this? I don't know. Does this even check? Assuming P1 wins and P2 wins exist, are those the only errors? What else is an error here? Expected array with fixed size of 6. Oh, it's 7. Okay. And then I passed something in the wrong order. Oh, the universes. Why did I put the universes there? I'm getting it out of order. So it's P1 score, P2 score, then the universes times U goes here. That was a dumb mistake. Okay, now P1 wins, P2 wins, and then we still have an enumerate. Method can't be called on this, just unsatisfied trait bound. So you can't do it, and can I do an iter enumerate? And hit F1 again? Oh, now everything's blowing up. Expected U64 found U size. Oh, okay, that's easy. That's easy fix. As U64. Okay. All right, so we're just down to the wins. So all we need to do is figure out the wins from this, right? And how do we do it? Do we just pass in a mutable reference? P1 wins. Can we just do it this way? I don't know if this is going to work. P2 wins. And then just start it out as 0. Expected type. Oh, mute 64. U64. There we go. Okay, it's not complaining that badly. And then we need to actually pass them in here. This is where it blows up, right? This is where Rust tells me I'm passing mutable references to things and things die. Yeah. Oh, wins. Well, it's not complaining about the lifetime yet. Oh, I forgot to make this mutable. And we have 2 warnings, and I think it's just because part 2 is not being called. So let me switch back to the, what was the test input again? 4 and 8. And then we're going to call, well, we're going to create our wins. Let mut P1 wins equal 0. P2 wins equal 0. And then just call part 2. The current score for P1 is 0. Current score for P2 is 0. The number of universes has to start at 1. Otherwise, I would have thought 0 just off the top of my head, but it's got to be 1, right? Otherwise, this multiplication will always end up being 0. Even though there's no universes, so this might not be the right. Is player's 1 turn? Yes, it is player's 1 turn. So we'll say true. A player's position. Oh, we already have that one. And P2 pause, and then we're going to pass in mutable P1 wins and a mutable P2 wins, and then we're going to say day 21 part 2 is what are we looking for? The one that's bigger. So P1 wins max, P2 wins. Does that check? It does not check. Oh, right, we made those. Okay. Oh, and then if I change that, it's going to change everything, right? Everything's going to blow up. Maybe I can make these I64s. Oh, we can't add the scores. All right, we can make those I-60. Hopefully it doesn't wrap around. Okay. Oh, it's slow. And it came up with the wrong answer. Huzzah! Okay. This is still... Oh, no, that's not right. It's 4 and 8. Did I... Come on. 4 and 8. How did I break part 1? Oh, that was my puzzle answer. 739, 785. Okay. But part 2, we were looking for this one. Yes, I'm on test input. I was running test input because I wanted to look at these numbers here. And it's pretty clear whatever I'm doing, I did wrong. So that's fun. It took 4 seconds to come up with the wrong answer. All right, let's try to... I think my reasoning is sound. It's just maybe my implementation is bad. Where could I be going wrong here? I mean, we're enumerating over these things. We have a 0, 1, 2, 3, 4, 5, and 6 for the enumerate. So it should end up being, this should end up being 3 through 9, which is what we want. This P1 score plus P1 next. Right, because we're adding in the score we just got, the place we got. That's correct. P2 score. We multiply the universes times the value in there. P1 next is going to be the next location for that, and P2 next is the player's position, player 2's position, and then we have 1 and 2 wins. And then we do the same exact code. I didn't mess up at P1 and P2, right? We have the P1 score plus P2 score. We have the number of universes. We flip the turn again, right? Because this is false and now it'll be true. Player 1 position doesn't change. Player 2 position goes to next, and the wins are passed along. Yeah, I don't know what's wrong here. If somebody sees my bug somewhere, please shout it out, because I'm not sure what's... And I know we're not wrapping integers because Rust would warn us if we tried to add a number that overflowed. So I know it's not an overflow issue. Yeah, I don't know. Yeah, I was hoping to see this number here. Let's print them both out and see if that helps me understand what's going on. I doubt it will, but it's something to do while I'm thinking here. Yeah. Oh. Huh. Huh. Oh. Duh. Okay. 4 and 8. I was using the after we did part 1. That was dumb. Okay, hopefully that was the bug. I was thinking my logic makes sense. So, do we have the two numbers after 4 seconds? Okay. Okay. These are the right numbers now. All right, let's switch this back to the max. And that'll give us that. And I don't want to put 4 and 8 now here. I want to put my input. What's my input? 3 and 5. And run that. And that failed. Because I forgot to update this. I'm feeling good about this. Yeah, I slowly worked my way through that. That took a little bit of doing. So Crazy Wolf was asking, how did I come up with this list of numbers? And I did walk through that in the beginning of the stream of how the only reason I came up with the solution was coming up with these numbers here. And basically this is for 3. To roll a 3, there's only one way to roll a 3. For 4, there's 3 different ways to roll a 4, right? Because you can roll, if you think about the rolling 3 3-sided die, it could be 1 1 1, and that generates 3. But there's only one way to get that. There's also only one way to get 9 is if you roll a 3, and a 3. And there's only one of those. But there's 4 different ways to get a 3. You can either roll a 2 1 1 will get you a 3. A 1 2 1 will get you a 3, or a 1 1 2 will get you a 3. So there's 3 different ways to get 4. Sorry, I did a really bad explanation there. So a 2 1 1, a 1 2 1, or a 1 1 2 will all get you 4s, and there's 3 different ways to do that. So I reasoned that we can just say, you can take the number of universes where you can get a 4 and just multiply that by how many universes you've gone through already. And just keep working your way down the universe black hole until you've hit your score of 21. Right? And then for 5, there's 6 different ways to get a 5. I can outline those, and then you can roll a 3 1 1 will get you a 5. A 2 2 1 will get you a 5. There's 5 different ways. So there's a 2 1 2 and a 1 2 2, and then a 1 3 1 and a 1 1 3. So there's 6 different ways to get 5. And then I'm not going to do the rest. There's 7 different ways to get 6. And then 7, 8, and 9 have 6, 3, and 1 also. So by multiplying the number of times you can get to that universe by how many universes you've already gone through to get your current score, you get the number. You know what? I haven't even tried running this yet to see if it's correct. Oops. Here's the problem, is that I now have uncompilable code, so I can't run it. There we go. So my answer is this number. And this number is That's the right answer. Oh, thank goodness. Because if that wasn't, I would be dead in the water. I think I got really lucky just noticing this thing here and saying, oh, you can just multiply. It took quite a bit of brain power, though. Oh, it doesn't like this. What's wrong with this? Too many arguments. Too many arguments. Should we clean that up now that we have this working? What's Rust's limit? Oh, it says it right here. 8. It's got 8 arguments, and 7 is the recommended max. Okay. Let's clean that up. Why not? Wow. Yeah. Okay. That's painfully painful. Can we just make a? I don't want to just create a new struct each time, because I was thinking I could just throw everything into a struct except for the wins. And then I'd have to create a brand new struct each time I go through. I can change things into tuples. Would that help? Let's do this, the scores as tuples. Scores. I-64, I-64. There. And then we just pass in a tuple here. Let P1 score equals scores.0. Let P2 score equals scores.1. This is kind of ugly to make this work, but okay. And now we should be down to 7 7 arguments. Yeah, okay, so now it's happy. Let me quit out of this because it might have gotten reformatted. No, it's still long. What else can we do? We can do P1 pause and P2 pause as a tuple. Positions. And then we can say let P1 pause is positions.0 and P2 pause is positions.1. Oh, and then I got to pass them in. P1 next to P2 pause. P1 pause to P2 next. Oh, and then I got to pass it in up here. Okay. How does that look? It's still all spread out. Dang. Oh well. I think this is harder to read, but it keeps it within the line length, so I guess we're okay. And we'll just leave that. We'll just leave that as that. Day 21, part 2. Push. Okay. Day 21 done. And I barely understand my own solution. Let me just take another look at it here. So we loop over each possible outcome, and then we recurse down to calculate for that particular outcome. And we know how many times we could get this outcome. So we multiply that by how many universes we've already visited. And we keep going like that. I guess we could break here. If the score, because we could check the score here rather than up here. But this is the way my brain put it together, so I guess this is the way we're going to stick with it. And it comes up with the answer in a reasonable amount of time. What was it, 4 seconds or something? It's pretty slow. Let me try running it release and see if that's any faster. 6 seconds I took. Okay. So less than half a second. That's not bad. I can live with that. And I pushed it right here. Okay. So that's day 21 done. And now what I'm going to do is I'm going to switch over to my normal Rust stream, which is roguelike programming. We had a bug yesterday, and I was going to think about what the bug could possibly be, and I haven't thought of anything. The bug with the roguelike is that it won't generate, it won't spawn items. So let me quickly update my stream description here. Roguelike tutorial.